Find dy dx at x equals pi when y equals secant x times ln of x. Ugh. All right, so this is not going to be pretty at all. In fact, I think this is actually not going to be so bad. This is what's going to happen. We're going to need the product rule for that guy right there. All right, so product rule, if you forget, is the ddx of u times v is going to be u prime v plus v prime u. So what I need to do is figure out what u prime is, right? U prime is the derivative of secant. The derivative of secant is secant x times tangent x, right? V prime is going to be the derivative of ln of x, which is just 1 over x. So coming back over here, right, we can now kind of put things together. dy dx is going to equal u prime v, so secant x tangent x times, oh, did I do the v? No, times v, so times ln of x, not pretty, plus v prime, which is 1 over x, times u, which is secant x. Okay, so dy dx is going to equal that. So let me actually erase that. I don't really need to simplify anything. There's nothing in here that needs to be simplified. There's nothing we could do. It's just now what we have to do is plug in pi. So if I plug in pi, I end up with secant pi tangent pi ln pi plus 1 over pi secant pi. So pi's everywhere. It's like Thanksgiving. All right, so hopefully we remember this stuff. Secant of pi is -1. Okay, and of course that comes from the fact that you have 1 over cosine pi. So secant pi is -1. Tangent pi is nothing. So I don't really care what ln of pi is because it's just going to disappear anyway. Plus 1 over pi. Secant pi, again, is -1. So you completely cancel out, and 1 over pi times -1 is -1 over pi. So that's going to be my guy right there. So we used product rule to figure out this stuff. We plugged in pi a bunch of times. We really only needed it once. And yeah, that's our answer. Fun stuff.